Okay, let's have the phase diagram. So phase diagram, this is a graphical way to depict the effects of pressure and temperature to the phases of a substance. Pag sinabi nating phase of a substance, we are referring to the solid, liquid, and gas. Okay, so typical phase diagram, ganito ang itsura niya. So you have on the x-axis. So x-axis is the temperature. So more likely as you go to the right, so temperature is increasing. So on the y-axis, on the other hand, you have here your pressure. And as you go up, the pressure also increases. Okay, so the three phases na sinasabi dito ay yung ating solid. So, more likely, nandito siya, no, sa malapit sa pressure. So, kasi ang solid ay favored at low temperature, at high, or at any pressure, no, for this case. Then, you also have so that's the solid. Then, you also have the liquid naman, dito naman sa portion na to. Okay? And then, you have the gas on this part, sa baba. Gases are favored at low temperature, low pressure rather, okay, and high temperature. Okay, so dito. Okay, so there are boundaries in the phase diagram that will separate these three phases. So ito, tulad nito, ito yung boundary that will separate solid from liquid. And if, say for example, at constant pressure, dito kunyari, there are changing temperature. So, ito yung temperature 1. At the same pressure, temperature 2. Yan, temperature 1. And then here would be temperature 2. So, there will be a change in the phase, no? So, from solid, mag-melt daw siya to liquid. Okay? Ganun din naman, vice versa. If, say for example, at this point, you have here a certain temperature, lalamig, no? Bababa yung kanyang temperature at same pressure. So, ano mangyayari naman? Freezing naman daw. So, from liquid to solid. So, the boundary is called as the fusion curve or melting curve or freezing curve because here, it is where melting or freezing happen. Okay? Now, another boundary would be on this side. Dito naman daw sa baba. Balitan natin yung kulay. Okay, so dito naman sa baba. Okay, so here, this is also known as the sublimation curve. So from solid to gas naman daw yan. Or deposition curve from gas to solid. Okay, so if, say for example, there's a solid, no? May solid siya. There's a solid at this point at certain pressure. Okay? And at certain temperature. If, say for example, at constant temperature, walang binagbago sa temperature niya, pero bumaba ang pressure niya at this point, so pwede rin magkaroon ng phase change. And that would still be from solid to gas, that is sublimation. So, hindi lang nangyayari ang phase change when temperature changes. Pwede rin na mangyari na phase change occurs when pressure changes. Okay, and the last boundary is known as the vaporization curve or condensation curve. So, if from liquid to gas, that would be vaporization, and from the gas to liquid, that would be condensation. Now, there are 2 points here in the phase diagram. Meron tayong triple point. Ano ibig sabihin ng triple point? The solid, the liquid, and the gas could coexist. Okay? So, they could be present. Pwede siyang maging solid, pwede siyang maging liquid, at maging gas at that certain temperature and pressure. Meron din tayong tinatawag na critical point. Dito naman sa taas, yung critical point. Okay, so this is the temperature or the situation with a certain temperature and pressure wherein the supercritical fluids exist. Okay, so dito naman sa critical point, dito nagkakaroon ng supercritical fluids wherein the fluid will exhibit similar properties to that of the liquid and to that of the gas. So parang inextinguishable na siya yung sa property niya kung liquid ba siya or gas. And above that critical point is the supercritical region. Dito daw. Dito yung supercritical region wherein the supercritical fluids exist. Okay. So let's have, ito yung mga features ng phase diagram. So you have your x-axis, the y-axis, the three phases, and then you have here the equilibrium, which is the triple point. Okay. Or rather, this is the conditions, rather, the curves. Okay. And then you also have here your triple point, your critical point, your fusion curve, your vaporization curve, and the sublimation curve. Now, we have here the phase diagram of carbon dioxide. Tingnan nga natin kung ano ang itsura ng phase diagram ng carbon dioxide. So, the slope of the line between the solid and the liquid is positive. Asan ba yan? The solid and the liquid, so ito yung boundary daw niya, is positive. Meaning to say that it is more inclined to the right. So, pag ganun, papunta siya sa right. Para maging negative siya, pakatulad nun sa water. Ito. Okay, so papunta naman siya sa left side. Okay, so this one, pag papunta sa left, okay, that would be, or inclined to the left, that would be negative rather than positive. Okay, so for this case, balik tayo kay carbon dioxide, so positive ang kanyang sublimation curve, ang kanyang fusion curve rather. Fusion curve ay positive, at ang critical point niya is at 72.9 atmosphere and 31.1 degrees Fahrenheit. So, yung sinasabi ko sa inyo kanina, the region above the critical point is the supercritical region. Okay, dyan makikita yung supercritical fluids. Now, the triple point of carbon dioxide, wherein the solid, liquid, and gas could coexist, is at 5.11 atmosphere and negative 56.6 degrees Celsius. So, way beyond the freezing point of water, no? Dapat super lamig na to para ma-meet niya ang kanyang triple point. Now, the triple point, take note, the triple point of carbon dioxide is above 1 atmosphere. Remember, 1 atmosphere is the standard pressure. So, above daw ang kanyang triple point. That's why at normal condition, which is 1 atmosphere, ang nakikita lang natin ay yung solid and gas state ng ating carbon dioxide. That's why yung mga dry ice natin, pagtanggal natin sa lalagyan, from solid, nagsugo sila ng sublimation, and they will turn to become vapor. Kaya, ang naging effect nito, maganda yung ginagamit nila to sa mga stage presentation or stage effects, no? Okay? Now, pagdating naman kay, let's have the phase diagram of water.